everyone, welcome to Vidmahi Maths Academy. In today's video, we will learn a simple and systematic method to find the domain of different types of functions. Many CET questions on functions, inverse trigonometric functions, logarithms, and continuity directly or indirectly depend on finding the domain. Today, we will learn the three golden rules of domain that can help you to solve the most of the CET questions easily. So, let's get started. To find the domain of the function, you should remember these three golden rules. First rule: if the given function is of the form numerator by denominator type, then in that case denominator should not equal to 0. Second rule: if the given function is of the form root of expression, in that case expression should greater than or equal to 0. If third rule: if the given function is of the form 1 by root of expression, in that case expression should greater than 0. These are the three golden rules. You should keep these three golden rules in your mind. So now we will solve the problems based on these three rules. First one: domain of f of x is equal to x by 1 minus mod x is, and the options are R minus closed interval minus 1 comma 1, B minus infinity comma 1, C minus infinity comma 1 union 0 comma 1, D R minus 1 comma 1. So this is based on first rule of the domain, that is numerator by denominator. If it is of the form numerator by denominator, then denominator should not equal to 0. So according to this rule, here the denominator is what? 1 minus mod x. So that 1 minus mod x should not equal to 0. Then minus mod x is not equal to minus 1. So that mod x is not equal to 1. Mod x is not equal to 1 means what? X is not equal to plus or minus 1. So therefore domain of this function is equal to whole real number set except minus 1 comma 1. So option D is the correct one. Next, second one: the domain of the function f from R to R defined by f of x is equal to square root of x square minus 7x plus 12 is, and these are the four options. Now this question is based on second rule of the domain of the function. Second rule to find the domain of the function, that is root of expression. If it is of the form root of expression, then expression should greater than or equal to 0. So here the expression is what? X square minus 7x plus 12. Correct? So that x square minus 7x plus 12 is greater than or equal to 0. Is greater than or equal to 0. Now Observe this left hand side inequality. X square minus 7x plus 12. So this is of the form quadratic equation. So factorize the term first. So that split the middle term. Split the middle term. X square minus 4x minus 3x plus 12 is greater than or equal to 0. Next, x common x minus 4 minus 3 common x minus 4, which is greater than or equal to 0. So that x minus 3 and x minus 4 is greater than or equal to 0. So now the roots are x minus 3, that is x is equal to 3 and x is equal to 4 are the roots. Now by using wavy curve method, we have to find out the interval. So for that, we have to consider a number line. Number line. So this is a real number set. So in that real number line, consider these two values. X is equal to 3, x is equal to 4. Represent these two values, 3 and 4. This is minus infinity. This is plus infinity. Now, here there are three intervals: minus infinity, comma 3, minus infinity to 3, 3 to 4, 4 to infinity. Now, in between minus infinity to 3, consider any one of the value and substitute that value in this inequality. Okay, for example, if you consider 0. Okay, 0. Now substitute the value here. 0 minus 3. 0 minus 3 is what? Negative. 0 minus 4, that is also negative. Negative into negative is what? Positive, that is greater than 0. That means in this interval, if you consider any value, the inequality is greater than 0. In between 3 to 4, consider any one of the value, for example 3.5. Substitute here 3.5 minus 3, that is value is positive. 3.5 minus 4, value is negative. Positive into negative, that is negative. So that is less than 0. That means in between 3 to 4, the value of the function is less than 0. Next, 4 to infinity. Consider any one of the value, for example 5. Okay, if you consider 5, 5 minus 3 is what? Positive. Again, 5 minus 4 is positive. Positive into positive, positive. So that is greater than 0. In this interval, the function is greater than 0. So observe this function x minus 3, x minus 4 should greater than or equal to 0. That means in between minus infinity to 3, in between minus infinity to 3 and 4 to infinity, the value of the function is greater than 0. So therefore, domain domain of this function is equal to minus infinity comma 3 including 3, closed interval 3, because here greater than or equal symbol is there, so that's why closed interval 3 union 4 comma infinity. 4 is including, that means closed interval 4 comma infinity. So therefore the domain of the function is minus infinity comma 3 union 4 to infinity. So that option D is the correct answer. Next, the domain of the function defined by f of x is equal to root of 4 minus x plus 1 by root of x square minus 1 is, and these are the four options. This function is the combination of two rules of the domain of the function. To find the domain of the function, it contains the two rules. First one, it contains under root of expression. Second one, it contains 1 by root of expression, and the combination of these two rules. Correct? So, first consider this first rule, that is, consider root of 4 minus x. According to the rule of to find the domain of the function, if it is a root of expression, expression should greater than or equal to 0. That means 4 minus x is greater than or equal to 0. So that here minus x is greater than or equal to minus 4. So minus both the side minus will be there. To remove the minus, we have to multiply both side by minus, so that this greater than or less equal inequality changes to less than or equals. So that means x is less than or equal to 4. X is less than or equal to 4. Okay, keep it as it is. Next, again consider 1 by root of x square minus 1. 1 by root of x square minus 1. For this, so this is of the type 1 by root of expression. 1 by root of expression means here expression should greater than 0. That means x square minus 1 should greater than 0. So observe the left hand side. So that is of the form a square minus b square. So we can split x minus 1 into x plus 1, which is greater than 0. Now by using wavy curve method, we have to find out the interval. So for that, consider a real number system. So consider a number line. On this number line, represent these two numbers, x is equal to 1 and x is equal to minus 1. So minus 1 is smaller value, first represent that, after that plus 1. So this is minus infinity and this is plus infinity. Now here there are three intervals, minus infinity comma minus 1, 1 to infinity, and minus 1 comma 1. There are three intervals. Now in between minus infinity to minus 1, consider any one of the value. Consider any one of the value. For example, if you consider minus 2, substitute this minus 2 in this inequality equation, inequality in this inequality. So minus 2 minus 1, minus minus, so that means that is negative, minus 2 plus 1. So there we get negative, negative into negative, positive, that is greater than 0. So therefore in between minus infinity to minus 1, if you give any value, the function value is greater than 0, always greater than 0. Now, in between -1 to 1, consider any one of the value. For example, if you consider 0. Okay. Okay, 0 minus 1, that is negative. 0 plus 1, positive. Negative into positive, negative. So that in this interval the function is always less than 0. Next, in between 1 to infinity, consider any one of the value. For example, 2. So substitute here. 2 minus 1 is negative. 2 minus 1 is positive. 2 plus 1 is positive. Positive into positive is positive, that is greater than 0. So in this interval the function value is greater than 0. So that for this condition, x belongs to what? X belongs to minus infinity comma minus 1 open interval, because here only greater than symbol is there, so that's why minus infinity comma minus 1 union open interval 1 to infinity. 1 to infinity. So finally, we have to combine these two values, that is x is less than or equal to 4, x belongs to this interval. Combining these two, consider the common interval. If we combining these two, we have to consider the common interval and write down the domain. So for that, uh, consider a line. So this is -1, this is +1, and one more line is 4. Okay, this is minus infinity and this is plus infinity. So that minus infinity comma minus 1 open interval union 1 to infinity. Next, x is less than or equal to 4 is there, correct? So for that, consider a closed interval on the 4. So if we combine these two intervals, we get, therefore domain of this function is equal to minus infinity comma minus 1 union open interval 1 comma 4 closed interval. So that the answer minus infinity comma minus 1 union 1 to 4. Here the first option is the correct one. First option, minus infinity comma minus 1 open interval and union 1 to 4. That's all for today's session. If you found this video helpful, please like, share, subscribe to the channel and press the bell icon so you don't miss the next part. Thank you for watching. See you in the next video.